Good afternoon. I am from Siberia, city Tomsk. It is a bracket device with titanium nickelite wires with super elastic. Super elastic titanium nickelite wire used in manufacturing bracket system. However, it has been found that wires are prone to brittle fire in oral cavity after several months. Origin this effect is hydrogen embrittlement. However, up to present time, there were no attempts to study effect of grain size in titanium nickelite-based alloys on hydrogen embrittlement effect. And this work is to investigate the effect of hydrogen-induced friction of titanium nickelite-based alloy. In this report may performed first studies comparing inelastic properties and friction of the wire specimens of binary alloy of titanium nickelite with coarse grain and ultrafine grain microstructure under action of hydrogen. Two types specimens produced by Matek company composition with ultrafine grain structure with grain subgrain size about 0.1 micron. It is microstructure. And coarse grain, specimens with coarse grain structure, with grain size about 10 microns. After recrystallized annealing, specimens have been charged electrolytically with hydrogen in 0.9% natri chlor, current density, charge time was 3 hours, hydrogen concentration was measured using hydrogen analyzer LECO. Inelastic properties were determined in torsion test by cyclic loading and unloading scheme under isothermal condition. Scanning electron microscopy was conducted using Zeiss scanning electron microscope. It is temperature magnetic transformation. Table 1 shows the both ultrafine grain and recrystallized specimens at room temperature had the B2 phase structure before hydrogenization. In this slide, shown engineering stress-strain dependence during torsion of ultrafine grain specimens and coarse grain specimens. It is stress plateau indicating the occurrence stress-induced magnetic transformation. Magnetic shear stress about about 400 and in ultrafine grained and coarse grained specimens. Transition from ultrafine grained structure of specimens to coarse grain result in this softening. Super elastic effect hydrogen. This is accumulation and recovery inelastic strain at the first loading-unloading cycle in coarse grain specimens. Testing temperature was room. After hydrogenization, before hydrogenization, the hydrogenated coarse grain specimens achieved stage of dislocation strengthening early as compared unhydrogenated specimens. It is accumulation and recovery inelastic strain at first loading-unloading cycle in ultrafine grain specimens. Hydrogen has weaker effect on the inelastic properties of ultrafine grain specimens than coarse grain specimens. Second loading cycle up to failure of specimens. It is loading, loading and loading. Господи, второй цикл там да. Second cycle ultrafine and coarse grain up to friction. Hydrogenated specimens subject substantially lower ultimate strain before failure. Against approximately 50% and 44% in unhydrogenated specimens. Torsion failure. Torsion failure are different from tensile failure. In this, the a little localized reduction of area of elongation. Ductile failure, flat surface, brittle and angle. Torsional fracture, titanium nickelite wire, without hydrogen. Ductile fracture, flat surface, dimple near center wire. It is image of fracture surface of hydrogenated titanium nickelite specimens with coarse grain structure. Brittle fracture, spiral cracks, delta L distance between spiral cracks. It is brittle flat lace dipoles. Cracks on the surface of fractured hydrogenated recrystallized specimens. Many cracks. Cracks width depends on distance. Specimens from fracture plane. It is image of fracture surface hydrogenated titanium nickelite specimens with ultrafine grain structure. Only one spiral crack, also brittle fracture. In ultrafine grain structure, brittle lay about 3 micron. In coarse grain structure, brittle lay about 30. Thank you. Micron. Conclusion. Various specimens absorb more than 2 hydrogens in this coarse grain structure. Superelastic after hydrogenation remain high under external loading of less than 600 megapascal. Hydrogen has a weaker effect on the inelastic properties. Ultrafine grain than coarse grain specimens. Heterogeneous specimens with coarse grain and ultrafine grain structure destroyed briefly, but the of bright light is different. Thank you for attention.